Hello. Today we are going to calculate betas and Sharpe ratios to compare performance of 10 these decile portfolios here. These are portfolios that are formed based on the size of the stock. Decile 1 contains small stocks, decile 10 contains the largest stocks. These data are available on Ken French's webpage, and I would like to thank him for letting us have the data. In this column here, in column C, I have the risk-free returns. This is the return on a 1-month T-bill. And right here, I have the market minus the risk-free rate. The market is the valuated in NYSE AMX NASDAQ index. And so those are excess returns on the market. To start with, I'm going to create excess returns on my decile portfolios. These are the risk premium. So to do that, I will simply take the return on the portfolio minus the risk-free rate. Throw some dollar signs in there so I can copy it over and then copy it down. Oops. Sorry, risk-free rate. Copy it over for all 10 portfolios. Copy that down. And I've created excess returns on my assets themselves. Now what I'm going to do is for the 10 decile portfolios, I'm going to calculate their average excess returns, their capital asset pricing model betas, the expected return that the CAPM says these firms, that the portfolio should have earned. I'll calculate their alpha based on that, and then their Sharpe ratio, and we can compare them and see how well they did relative to the CAPM and to each other. So in this cell, I'll just put in the average of my excess returns here. And I can copy that over for all 10 portfolios. The beta is just like in the notes. Here I'm going to calculate the covariance of the excess returns on the asset with the excess returns on the market proxy, divided by the variance of the excess returns on the market proxy. So I'll put in the formula, covariance S of my asset, and then zip over to my market excess returns, which is all the way back over here. Close that parenthesis. I'm going to divide that by the variance of my market proxy again. A closing parenthesis, enter. Let's take a look at that. So this is the CAPM. This cell right here contains the capital asset pricing model's beta, which is its measure of market risk for the small firm portfolio. Let me stick in some dollar signs because I want to lock down the market proxy. And I can copy that formula over and calculate the beta for the rest of the portfolios. And you can see that as we go from small firms to larger firms, the market risk of those portfolios decreases almost monotonically, so that the largest firms have the least amount of market risk and the smallest firms have the most amount of market risk. All right, now we can calculate the expected return that CAPM predicts. That's simply going to be the firm's beta times the average excess return on our market factor. So go back over here one more time, punch that in. And for portfolio 1, we can see that this CAPM predicts that portfolio 1 should have earned a much smaller excess return than it actually did. Put some dollar signs in here again so I can copy it over one more time. Let's see how it looks for the rest. So you can see that as we go from small firms to large firms, that the CAPM starts, it's pretty close most of the time except for the very small firm portfolio. And in fact, that's what alpha is. Alpha is the difference between what the firm or the portfolio actually returned and what the CAPM predicted it returned. Copy those over and let's take a look at those for a second. So these are, in reality, risk-adjusted returns for the 10 portfolios. And the risk they're adjusted for is beta risk. So we can see that, of course, we want the bigger these are in a positive direction, the better. So it looks like the small firm portfolios outperformed what CAPM said they would get. And as we move down towards the larger firms, you can see that the larger firms performed almost exactly as the CAPM, maybe just a little underperformed what the CAPM said it should do. All right, now let's calculate the Sharpe ratios. Sharpe ratios for the individual assets are just the risk premium for the asset. That's the expected risk premiums right here, because I didn't need that parenthesis, divided by, now I'll just put in the standard deviation of that particular portfolio's excess returns. Looks like I need a parenthesis here. Put that in. And there's the Sharpe ratio. So that's the slope of a line running from the risk-free rate through this first decile portfolio in our expected return standard deviation space. And if I copy that over, I can get the Sharpe ratios for all of the portfolios. Again, here, bigger Sharpe ratios are better because it gives us a better investment opportunity. If we were just looking at that one asset, combining that one asset with the risk-free rate, I should say, and we can see that based on this measure, it looks like the middle size portfolio actually would be the best investment for us in terms of adjusting for total risk. So this is a total risk adjusted measure. It's not a return, it's a Sharpe ratio. But if we look at alphas, it looks like based on alphas, the small firm portfolio would be better because it provides the best risk-adjusted return when we adjust for market risk. The difference between these two is due to the fact that one is adjusting for market risk, that's alpha, and one is adjusting for total risk, which is the Sharpe ratio standard, which uses in the denominator the standard deviation. Another thing I can do with these data is let me copy them down. I'll put them right here. I will paste special, just the values, and I will transpose the data so I get them in columns. And then what I want to do is plot, first off, I'm going to plot the security market line. In this case, the security market line is going to run through the origin. So if I make a table that says standard deviation and expected return, then for the risk-free rate, I'm going to put in a 0 and a 0. That puts the risk-free rate down at the origin. And actually, I don't want standard deviation, I want beta. But the beta of the risk-free rate is 0. And the beta of the market risk premium is going to be 1. And then I'll put in the expected market risk premium right here. All right, let me plot that. Now, a line running through the origin and this 0.1 and 0.64 represents the security market line. We're running this through the origin because we're working with excess returns. So we've taken the risk-free rate that is the intercept in the usual version of the CAPM and we've stuck it over in the other side of the equation. So let me highlight these data. Actually, what I'll do is I am going to first plot the betas and the expected returns of my portfolios of data. So because I want the betas to show up on the horizontal axis, I'm going to flip these two columns. So I'll put beta first and expected return second. And then I can highlight these data, insert a scatter plot, and that gives me a plot of the expected returns that the portfolio has actually earned relative to their market risk, which is beta along this axis here. Now I'll add in the security market line. Plot the betas, plot the expected returns, and say OK. And let me add a trend line to that. And I'll just extend that out a little bit so it looks pretty. And now we can compare visually how these portfolios did in terms of expected return relative to what the CAPM said they should do, which would fall on this line right here. So this positive distance happens to, for this is the small firm portfolio, this distance between the line and this data point right here in terms of expected return is the CAPM alpha. You can see that all of them are positive except for one little negative one down here, which happens to be the large firms. What you can use this picture for is to answer the question of how well does the CAPM predict these portfolio returns. You can see that it looks like it's biased a little bit negative relative to what actually happens in the data. And this would be evidence against the CAPM being a good model for these. If the data points were all around this line, it would be even more evidence that the CAPM is not doing a good job predicting the returns on these portfolios. If instead all of the portfolios lay exactly on the line, then we would say the CAPM is a really good predictor of their expected returns based on the market risk of those portfolios. There you go. I hope this helps you understand how to use the CAPM and Sharpe ratios to evaluate which portfolio to invest in.